Hi, my name is Matthew Shi, and I'm very interested in joining the next Fellowship.ai cohort. So, first, let me introduce myself a little bit. I'm originally from China. I got my college degree in China, majored in chemistry, and then I came to the US to pursue my PhD degree also in chemistry. My research mainly focused on renewable energy devices. So, in my research, we do a lot of data collecting, data analysis, and data cleaning. And later in my research, I got involved in simulative calculations of electron transfer, which is first I learned how to code and how to run simulations on those things, and it got me intrigued instantly. As much as into my research, it's the data that really gets me going. So I've always loved data and how love to discover the relationship between data, the information buried under seemingly random digits, and how we can use proper model to use those digits to give us information, valuable insights on decision making. So a few years ago, I started to learn machine learning. I took this boot camp, Thinkful boot camp, to learn a lot about becoming a data scientist, statistics, supervised and unsupervised learning, and then deep learning and big data. Deep learning is what I'm particularly interested in. Later on, I watched all the videos about fast AI, and I thought it was very helpful, and I learned a lot from it. And later on, I did a lot of projects using fast AI APIs. Um, and That's basically my background. I spent my past a few years working extensively with machine learning, particularly deep learning. I did a lot of computer vision, image classification, image segregation, and so on. And I spent a lot of time doing NLP projects. So, yeah, that's where I am right now. And then why I want to join Fellowship.ai cohorts. I think it's a very good opportunity for me to get my hands on real industrial projects, machine learning projects, and maybe I can learn a lot about building scalable machine learning models that can actually exploit in real life in industry. I think that's a very good experience for me. And also, I've always worked on projects by myself, and I think this is a good opportunity for me to work with others to learn how to work in a team environment, which will be in most companies for data scientist positions. I think that's very good too, and I look forward to learn a lot from my paired group partner and also the mentor, which should be from the real industry and knows a lot about how the cutting edge technology is going right now. So that's why I want to join this program. And next, let me talk about a little bit about the project I just did. So I chose the Food 101 image classification project to be my interview project. I think this is a very nice project, a computer vision classification project. And I think the main challenge here is there's just so many classes. There's 101 classes, and in each classes in the data set, each class has only 1,000 images and separated 750 for training and 250 for testing. So compared to the number of classes we're trying to classify, the number of images are numbers are fairly small. So I think in order to get a high top one or top five accuracy, I think I should do some data augmentation. So I tried different augmentation techniques. First, my first notebook is about exploratory data analysis of this data set, where I explored how the data structure what's the data structure of this data sets, how the images and their labels are formed in the folders and such, and how many samples I have, how are they distributed. Then I visualized a lot of the images in different classes, and within the same classes, how are they different from each other. So actually they're quite different, and there are a lot of they're quite different. Some of them are quite noisy. Some of them are quite um, the lighting extreme, the contrast kind of extreme, and a few of them are wrongly labeled. Then I try to visualize the data augmentation. I visualized how the different transformation techniques can transform this image to make the data set more diverse. So that's easier for the model to learn features and to get a better results from. That's the exploratory data analysis part. And then I started building the model where I used first I used the 256 by 256 pixels. Didn't get me high enough accuracy, and then I started using a better model, which first trained on 224 by 224, and then trained on 512 by 512. And finally, I achieved top 1 accuracy of over 88%, and top 5 accuracy over 98%. So that's a little bit of the project I did. You will see more details in the GitHub repo. I think the time's up.